I'd like to welcome everybody to class. This is the 14th class, the 13th that we've taught here. Remember, we did one lesson in midweek because we didn't get far enough and we wanted to get some stuff in the record on the class. If you also recall that at the beginning of last week's lesson, Nate mentioned that we had kind of maybe tried to do a couple things out of order. So he kind of backtracked a little bit to try to clear up a couple things. So I'm going to try to move the ball forward this morning, and what we're going to be talking about is distributed terms and testing syllogisms by rules. This is what we're going to be getting into here today. And I'm going to be fully transparent with you about this in the following manner, okay? So I've read this and studied this stuff myself in the past, but this is my first time actually teaching some of it. And so I'm a little bit just apprehensive about it because I don't want to do a poor job of it, but me and my personal understanding and then trying to bring it across the table to you guys, I'm just hoping I don't miss on that point. So I've already asked Nate that if there's something that he thinks I need to be more clear on or what have you, that he should feel free to interject, okay? So we're almost done looking at the issues of syllogisms and categorical statements. We've talked about a lot of things in this section of the class. Looking ahead towards sort of the end of the month and beginning of September as we wind this down, we have a few more topics that we want to look at, including more of the informal fallacies, and we'll be explaining what all that stuff is when we get there, okay? So let's talk first about distributed terms. When I hear, Nate brought up math a lot last time, when I hear the word distributed, I think of nightmares from high school algebra, talking about some of the stuff, and I was not a good math student, just to be frank, okay? Which is weird because I've loved logic for a long time, but I didn't necessarily like math. And they are somewhat related to each other, as we've sort of said. So when we talk about distributed terms, okay, so we've seen in 2 weeks ago, we talked about counterexamples, okay? So remember we talked about testing a syllogism's validity based upon counterexamples and proving the work, okay? So we've seen that counterexamples are one method for determining the invalidity of syllogisms. And just to be clear again, if you determine that a syllogism is invalid, do you have to then bother with discussing of truth, or can you stop? You can stop, okay? That's the way that this works, right? So truth is not the same, validity is not the same as truth when we're looking at syllogisms, all right? So this methodology is not very helpful, though, when the syllogism appears to be valid. So I'm talking there about the methodology of the counterexamples, okay? So it's not necessarily very helpful if the syllogism appears to be valid, and so we're going to need to talk about some additional ways that you can figure these things out, whether or not a syllogism is valid, okay? So because of this, as I just said, we need another method for testing syllogisms for validity other than just looking for counterexamples. Remember where we substituted terms and this sort of a thing, okay? So a second way is more of a rules-based method that centers around understanding what we're going to call distributed terms, all right? I'll hopefully explain all this. If I'm going too fast, you guys can stop me at the appropriate spots, and then we have some baked-in practice as well as normal, okay? So the terms in a syllogism are said to be either distributed or undistributed, okay? So it's either they're distributed or they're not. If they're distributed, we would say they're obviously distributed. If they're not distributed, we would simply say they're undistributed. It's not very hard to sort of figure at least that terminological aspect out. So what do we mean then? By distributed, we mean that the term refers to all members of its category, okay? We can tell if a term is distributed or not simply by its placement in a categorical syllogism. So notice this language here, all members of its category. What does that mean? What do you guys think that means? All members of a category. We've kind of talked about this before, right? Could we talk about trees? Could we have a term, and could we be talking about trees? Sure. Are there many different kinds of trees? What's up? It's not streaming? What about on Facebook?
Nope.
Well, I'm not going to stop to mess with it. So, everything appears to be set up correct up here, and it says it's on. I don't know. So we're not going to stop for that. Okay. So my point. So can we talk about trees? Yeah. Thank you. Yes, we could talk about trees. Okay. Are there more than one kind of tree? So if we're talking then about all trees, then we're talking about every single type or kind of what? Tree, right? So think about this definition. By distributed, we mean that the term refers to all members of its category. Okay? So in this example here, if we're talking about trees, this would mean that we're talking about all the different types of what? Trees. It's distributed across all the members of the category. Is everybody following that? Okay? So let's go to the next slide then. So we're going to look at our statements from last week. And notice that I've added the lettering that Nate talked about last time. So here we have an all SRP statement. All right? And remember, this is an A statement. And it's an A statement based upon, what was that term for that again? The mood, right? Nate, is that the right term? Yep. Okay, the mood that we learned about last week. So here, S, in any statement of this form, all SRP, the S is distributed, okay? And the P is undistributed. So what does that mean? The S refers to all of its class and P does not, okay? So we're talking about all what? Trees, all S, right? So the S refers to all of its class, and the P does not. So we would say then that the S is distributed, whatever the S term is, would be distributed in an A statement, and whatever the P term is would be what? Undistributed. Now why is that the case? The statement that all dogs are mammals says something about all members of the subject class, right? So the subject class is what? Dogs, right? So it says something about all members of the subject class. It's referring to all dogs, okay? But it does not refer to all members of the predicate class. What's the predicate class in this statement? Mammals, right? So it's saying something about some mammals, but is it saying something about all mammals? No. So we would say in logical terms that the S, dogs, is distributed because it's referring to all members of its subject class. And we would say that mammals, P in this case, is undistributed because it's not saying anything about all members of the predicate class. Okay? So as I just said, it's not saying anything about all mammals. It only says that some mammals are what? Dogs. Okay? So we would say that anytime we have an A statement, that the subject is distributed and the predicate is what? Undistributed, whatever you want to put in for S and P. Does that make sense? Okay? Stop me if you have a question. Is everybody good on that one? We still aren't live? Okay. No SRP or an E statement. Okay? In a statement like this, we would say that both S and P are what? Distributed. Okay? Now, why is that? S refers to all members of its class. No S. And so does P. No SRP. So, for example, in the statement, no dogs, that's S. Our cats, cats is what? P, right? So, for example, the statement, no dogs are cats, makes a claim about all dogs. They are not what? Cats. So, is it saying that all dogs are not cats? So, is it all-encompassing of all of its class, so to speak, right? And it says that, and about all cats, they're not what? Dogs. So we would say, using logical, or the language of logic or philosophy, that in this case, both S and P are what? Distributed. So anytime you have an S statement, an A statement, you know that the S is distributed and the P is what? undistributed. Anytime you have an E statement where no SRP, whatever S and P are, or an E statement, both are distributed, and the reason both are distributed is because in the statement, the terms are distributed across the entirety of whatever they are. Does that make sense? Any questions? Okay. Third, some SRP or I statements. In this case, both S and P are undistributed. Okay? No claim is being made about every S or every P. It only says that some of the S are P and that some of the P are what? S. Okay? So they're undistributed because they're not being used all-encompassing of the entire class that is being described. So they're both undistributed anytime you have an I statement, some SRP. It will always be this way, okay? So you can see now that what we're doing, or hopefully at least you can see, is that we're taking a concept here over the last number of weeks, and we're systematically adding a little bit more to it. So that as you get familiar with it, you can build onto that understanding and then apply it in other ways, okay? So before we move on from this slide, does anybody have any questions or comments?
When you do that I thing with the sum, you can state it that way, but does it necessarily mean that it's proven true to what you're claiming?
Okay. Can you give me?
Well, I don't know what this one's. We're still talking about cats and dogs, but if it says some dogs are cats and you're just saying some, like we haven't got to prove everything, but it seems like it's kind of a vague statement that if we're just putting it into a category that, yeah, that's true sometimes.
So
we have to prove it to make
I would say that what we're talking about now is not related to necessarily the truth of the statement, right? So we could say, on this example, we could say, some dogs are what? Cats. Spell cats right would be helpful. Some dogs are cats, right? Some SRP. Okay? Now, we know that that's what? False. But we're not talking about whether it's true or not right now. We're talking about the structure of the statement, right? So in the structure of the statement, this is undistributed. It's undistributed because we're only talking about somewhat. But then by virtue of the nature of the statement, we're also only talking about somewhat. Some cats. Okay? So obviously the statement doesn't make any sense, and I wouldn't agree with it, but we're not talking necessarily about the truth of the statement right now as much as tests for the validity of what's going on and being able to recognize patterns in the argumentation. Would you agree with that, Nate? So, some dogs are cats. That's undistributed because it's only referring to what? Some dogs. Now, that's obvious, right? But is the reverse also true? It is also only talking, therefore, about how many cats? Some cats. So, therefore, we would say that in that format or in that structure, that's what? Undistributed. Okay? Does that help, Bart?
I guess my only question is, or my concern is that as we use this, it seems like we're going from the specifics that we're stating, and then we go to, well, since S are P's, we get away from what we're talking about and start using letters and formulas and automatically come to conclusions, and I'm just worried that.
So yeah, I see what you're saying, but what we're talking about here is that any claim, any premise that you're going to make in a syllogism is going to fit any one of these structures, right? This is what we've been sort of building to, right? So what we're just saying is that structurally, this is what's going on. So you could take anything for S and P, swap it in, and figure out what's going on. Okay? Would you agree with that, Nate? Okay. So the fourth kind is some S are not P. All right? Some S are not P. So we could say here that S is undistributed. Okay, why? Because we're only talking about how many S? Some. Are not P, we could say that P here is distributed, because we're saying that all of P is not equal to what? Some S. So S is undistributed, P is distributed, it's referring to all of its class. All right? So consider the statement, here's an O statement. And remember, so Nate brought us through O statements last week. O statement, some astronauts, so what's the S? Astronauts are not men. What's the P statement? What? I'd say it's men. No, term I meant. Sorry. That would be P, right? So, some astronauts, is that referring to all astronauts? No. Not men, is that referring to all men? Yeah. So this statement says nothing about all astronauts. It only says that some of them are not men. However, it does not make a claim about all men. It's not making any kind of a positive claim about all men. This claim is that all men are not those astronauts being referred to in the subject, namely female astronauts. So if we go back here, look at the struct, look at what we're dealing with. So do we have one in A statement where the S is distributed and the P is undistributed? Do we have one kind in E statement where both the S and the P are both distributed? Then do we have a statement where you have S and P where both S and P are undistributed? And then in the last class here, or last type, we have a situation where the S is undistributed, but the P is what? So do we have four different types of situations going on here? And this is not the first time that we've seen this, right? This is the way things go. We've been building out these four different types of things now for a number of weeks, okay? So it may help you to remember, though, that the subjects of universal statements are distributed because they're universal what? If I'm talking about all dogs or all trees or all cats or all baseball players, it's obviously distributed because it's talking about all in that particular what? In that particular class, right? So it may help you to remember that the subjects of universal statements are distributed by definition of the word universal here, right? So that makes sense. And the predicate of a negative statement is also what? Distributed. So you can start seeing the patterns here. So let me just make sure that we get this. So in a universal statement, obviously the subjects, of a universal statement are distributed by definition of universal. And the predicate of a negative statement, obviously they're distributed by nature of the negative statement. Does that make sense? Okay. Now, let's look at some of the practice here that we got here. Okay. So with the person next to you, take a minute, and you guys in your notes on page, bottom of page 1, top of page 2, you guys have some practice here, and it says underline the distributed terms in the following statements. Okay? So it's asking you to identify the distributed terms. So quickly, remember our definition of distributed. Quickly, you guys can work together. I'll give you a couple minutes on this. Underline the terms in those statements that you think are distributed, and then we'll talk through. Top of page 2, you guys have some practice here. It's weird, we're live on the church website. hooked up through the Wi-Fi. I don't understand.
District Board none of that category.
It's sending it to the church website, so we at least have it.
Yeah, anything that universal, so. But not necessarily all that. Universal, no clear with respect to the category of yeah. Well, so it does, you have, so just the some and some. So anytime you have all of the category or none of the category is distributed. So anytime you not read it, no object. That's what you're gonna do. With the no statements, it's talking about no category of clear liquid versus the category of a solid object. All chess universe is 11 and not distributed here. All every kind of all interrelated chefs are a type of
All right, so let's talk through some of these, okay? So remember, we're underlining the distributed terms. So I think as we do this, you might see a pattern here, okay? So let's look at the first one. Some athletes are not honor students. What's the distributed term?
Honor students.
Okay, so why, Mike, is it honor students?
Because honor students is referring to all of that class.
Right, so notice the negative here. Some athletes, is that universal?
No.
No, are not honor students. Is there a negative there?
Yes.
Okay, so I'm just going to circle that and we'll look for a pattern here and see what happens, okay? So, not honor students. Honor students is referring to anyone who's what? An honor student. But we're saying here that some athletes are not this. So, this is this category here, this term honor students, all-encompassing of anybody who's an honor student, meets qualifications of an honor student. This is saying that some athletes are not this. So therefore, that is distributed, okay? Honor students. What about the next one, okay? No clear liquid is a solid. What are the distributed terms in this one? Sorry? Clear liquid. All right. Why?
no.
What?
Because it's no.
Okay. What do you mean because of the no?
It's same as what the top one is not. So
Okay.
negative. All clear liquids are not solid objects.
Okay. So no clear liquid is a solid object. Are there any others? Is anything else distributed?
A solid object,
All right. Why is that?
because no solid object is a clear liquid.
Okay. So notice we have these clues here, right? What about the next one? Some politicians are corrupt men. Are any distributed terms?
No.
Okay, I agree. Why not?
Because we're talking about some.
That's what he said.
That's what I said.
What are you saying, Mike?
We're talking about only some politicians, not all politicians.
Okay.
And the same with corrupt men.
So how is corrupt men the same as this? I agree with you, but I'm looking for somebody to explain it to me. How is corrupt men also undistributed?
Because all men aren't corrupt.
Okay? So you start seeing some patterns here. All chefs are contented people. What's distributed?
Chefs.
Chefs. Okay? All chefs are contented people. What about the next one? No Bible reader is an ignorant person. Did we get to the back or not?
We are now.
Is no Bible reader, is Bible reader distributed? Eli? Yeah. What about ignorant person?
Not very, not
reads the Bible.
No Bible reader is an ignorant person. Is ignorant person distributed?
No, because not every person is ignorant.
So now I have some disagreement. Does anybody think ignorant person is distributed?
Yes.
I agree. Why is it distributed?
Oh.
Go ahead. Why is it distributed?
I was just talking about the person, ignorant people. I didn't put that in words.
See? Yeah.
The easiest answer, because the rule says so.
Yeah, you could take the Nate answer and just say that's what the rule calls for.
Yeah.
Because it talks about ignorant people being ignorant people.
Correct. All right, so do you get the point here, right?
How
Yeah.
does that differ from corrupt men? Not all men are corrupt, and you're talking about ignorant person. Well, person is that, because men is all.
Men is plural.
Yeah, person is just one person.
Person is what?
Just singular.
Singular. Okay? Let's just skip to the end. Some Baptists are immersionists. Anything distributed? Anything distributed across the entire category? No. Okay? All right, let's go to the next bit of practice. Underline the distributed terms in the following syllogism. Okay? No wind instruments are guitars. All wind instruments are expensive instruments. Therefore, no expensive instrument is a guitar. So, in the first premise, is anything distributed? Wind instruments. Anything else?
Guitars.
Guitars is also distributed. Second premise, all wind instruments are expensive instruments. Anything distributed? Yes, because it's talking about what? All. All wind instruments are expensive instruments. Therefore, conclusion, therefore no expensive instrument is a guitar. Expensive instrument is distributed,
Guitar.
as is guitar. Okay? We're not talking about a certain type of guitar, this guitar, we're just talking about all what? Guitars. All right? Anybody need any extra clarifications there before we move on to part 2? I'm going to skip the next practice just because I think we get it at this point. And we'll go to part 2, which is testing syllogisms by rules. Okay. Now, before I start this part, though, does anybody have any questions? All right. Now that we've established the difference between distributed and undistributed, now we can go a step further as far as the idea of testing syllogisms. Okay. So there are 5 rules for testing the validity of syllogisms. If any of these rules are violated, then a syllogism is invalid. So if any of the following are violated, we could say and conclude, therefore, that the syllogism is invalid. If the syllogism passes all 5, then we would say that this is a valid syllogism. So, rule 1. We're just going to list the rules first, and then we'll talk about each one. Rule 1. In at least one premise, the middle term is distributed. Okay? Rule 2. If a term is distributed in the conclusion, it must also be distributed in its premise. So if it's distributed in the conclusion, does it have to be distributed in the premise? Okay? Rule 3. A valid syllogism cannot have 2 negative premises. Well, why would that just make common sense based on what you already know?
It's not really telling you a whole lot.
Right, like the 2 negatives generally cancel each other out. So that basic common sense thing is it applying here in Rule 3 essentially.
Yeah.
Rule 4. A valid syllogism cannot have a negative premise and an affirmative conclusion. All right? And rule number 5, a valid syllogism cannot have 2 affirmative premises and a negative conclusion. So we got some things here to play with now as we look at things, okay? Now, you guys have those out there in front of you. You need to be looking at those while we go to the next point here. So, compare the last three rules. So this would be Rule 3. A valid syllogism cannot have two negative premises. Rule 4. A valid syllogism cannot have a negative premise and an affirmative conclusion. And Rule 5. A valid syllogism cannot have two affirmative premises and a negative conclusion. So we're going to take those together as a group, okay? So compare the last three rules. If you give them some thought, you should recognize an implication of Rules 3 and 5, which I kind of already alluded to. If a syllogism has a negative conclusion, then one premise must be affirmative and the other what? Negative. That makes sense. Just on its face. Okay? Does everybody understand that? Yes? No? Okay. So you should also see from Rule 4 that if a syllogism has an affirmative conclusion, then it must have two affirmative what? Premises. See, that just makes sense from understanding the other. So you can take 3, 4, and 5, and you can just understand on their face some pretty, what would seem to be self-evident conclusions just from understanding what the rules say. Okay? So, we could say then that these last three rules, 3 through 5, can be combined even more briefly into this denser rule. The number of negative conclusions in a syllogism must equal the number of negative premises. The number of negative conclusions in a syllogism must equal the number of negative premises. Okay? So, if a syllogism has 0 negative conclusions, i.e. it's an affirmative conclusion, then it must have exactly one negative what? Premise. Okay? Nate, do you have something you want to add here?
No.
Okay. Does everybody understand what I'm driving at here with this? Okay? Yes? No?
Doesn't the last two bullet points contradict? Because if you have 0, the second to last would say if you have 0 negative conclusions, then you would have 0 negative premises.
Which one are we talking about? This one or this one?
The second to last.
This one?
Yeah.
The number of negative conclusions in a syllogism must equal the number of negative premises.
So if you have 0 negative conclusions, then you would have 0 negative premises.
So I either typed that wrong or I'm missing something. Let me check.
That would equal. Right here.
Yeah, that's sort of what I'm thinking. Because that's what the rule says, Nate.
No.
If a syllogism has,
Well, you would have to have a negative for this rule to count. There'd at least have to be one.
that's what I'm thinking. So at least one thing.
Apply.
So if a syllogism has 0 negative conclusions, i.e. an affirmative, okay, that's the last one. Let me go up here. The number of negative conclusions in a syllogism must equal the number of negative premises. Is that what I have? That's what I have.
Right, I think it's assuming if you have negative.
Right.
Then you must equal the negatives.
That is what it's assuming. All right. So, let's talk about each rule a little bit more specifically. Rule 1. In at least one premise, the middle term must be distributed. This means that the middle term must be either the subject of an A statement, the subject of an A statement, the subject or predicate of an E statement, or the predicate of an O statement. Okay? So look at, we have a little, so S on this little table here, you guys should have this in your notes, right? I gave this to you? Yes? Okay, good. It's there. Page 3. Okay? So, We have an A statement, so let's take the time to do this. An A statement represents what kind of statement?
Universal positive.
So all, how will we write that out?
All SRP.
All SRP. Okay, what is an E statement? This is where we're reviewing what Nate did last week. An E statement is what? If you don't remember, go to page 1.
Universal negative.
Go back to page 1 for E. No.
No SRP.
Yes. No SRP. What's the I? Some SRP. And the O?
Some S are not.
Some S are not P. Okay? So we got our abbreviations, A statements, E statements, I statements, O statements, right? Now we're over here and we're looking at subjects, predicates, right? So anytime you have an A statement, all SRP, the subject has to be what? What's D stand for? Distributed. Okay? No SRP, E statement, both the subject and the predicate are what? Distributed. Okay? And in an O statement, only the predicate is what? Distributed. So look at the rule. In at least, rule 1, at least one premise, in at least one premise, the middle term must be distributed. This means that the middle term must be either the subject of an A statement, the subject or predicate of an E statement, or the predicate of an O statement. In order to meet the qualifications of the rule, okay? So below is the chart showing you this, right? So you're probably going to want to keep this handy because it's probably going to help us throughout the rest of the lesson. So remember last time when Nate was talking about moods, Nate, you had we had MM and M. What was it?
Oh, how they go? Yeah, it would be slanting in, straight up in the middle on the right,
Yeah.
and left, then slanting away for 1, 2, 3, 4.
And so notice we kind of have that again here slightly, right? So we have one form where the subject is distributed on the top, and on the bottom we have a form where the predicate is what? Distributed. And then do we have a form towards the middle where both the subject and the predicate are what? Distributed. Right? So in other words, what I'm trying to draw out is that you can see that there's these patterns that start to develop as you look at this from a logical point of view. Okay? So, when you are examining a syllogism, the first rule, so we're still talking about rule number 1, is applied by looking at what type of statement the middle term is. Now, so here we have one. How do we determine the middle term of this statement? So now we're asking you to dig back into the reservoir of like 3-4 weeks ago and bring everything now to here, okay? So, the S is always the subject of what?
The conclusion.
Okay, so what's the subject of the conclusion? Angels. Okay? What's the predicate of the conclusion? Men. So just label that P. All right? So what's the middle term?
Mortals.
The middle term is what? Mortals. Mortals is the middle term. Okay? So, when you're examining a syllogism, the first rule is applied. Remember what the first rule was. I'll read it to you if you forgot. It's on page 2. If a term is distributed in the conclusion, it must be distributed in the premise. Okay? So, we know that the middle term is mortals. Now, is the term make sure I get this right here. So the first rule is applied by looking at what type of statement the middle term is. For example, consider the following, okay? So, is the middle term here, let's look at the conclusion first. Some angels are not men. Is angels distributed? No. Is men distributed? Yes. Okay? So what about the middle term? All men are angels. Is mortals, I'm sorry, I can't read. No wonder you're looking at me like I'm nuts. All men are mortals. Is mortals distributed? I say yes. Do you guys agree? It's
Yes.
okay. So this is distributed, right? The middle term is angels because it appears in both premises. So we've already figured that out, right? Mortals.
Mortals is your middle term.
What? So that's a typo. Should say mortals. Sorry about that. The middle term occurs in two types of statements. It occurs in an A statement. So this is an A statement. And it also occurs in an E statement. So no, the middle term is not distributed in the A statement because it is in the predicate. It is distributed in the E statement because both terms are distributed in an E statement. So again, you start building this out and it does tend to get a little bit confusing. But it's important for testing these things by the rules of how you could figure out if something is distributed or not. So besides that being somewhat, well, let's keep going. I think I got one more thing here. So the syllogism therefore passes the first test. So it passes rule number 1. When this rule is broken, it is known as the fallacy of the undistributed middle, where the middle term is not what? Distributed. Okay?
So it looks like the textbook was saying that the middle term was not distributive in the first premise, but it is in the second. Right?
It is here because it's referring to what?
Right. No.
No, no mortals. So the fallacy of undistributed middle. So in other words, it has to. My understanding is, in order to pass this test, it has to be distributed in both. Otherwise, it breaks the fallacy of it commits the fallacy of undistributed middle.
It says at least one premise in rule 1.
Right.
Do I contradict that here?
Well, it would be distributed in the second premise, so that would fit the rule at least one.
It would fit the rule of at least one. So this meets the rule, right?
Correct.
It does not commit the fallacy of undistributed middle. If you had two here that were undistributed, then you'd have the fallacy of what? Undistributed middle. That's the way I understand it.
So like if you reversed, like in the second premise, if you said all mortals but swapped mortals and angels, all angels are mortal. So all men are mortals, all angels are mortals, then you would have an undistributed middle term.
Right. And then you'd be committing the fallacy of undistributed middle. Okay?
Are we concluding that this statement is true then?
Well, we're concluding that it's valid, I believe. We're not concluding it's true. We're concluding that it's valid because it's not committing the fallacy of undistributed middle.
Well, we're only on rule 1 though.
Well, right. So far it's valid.
I don't even see it as valid this far because it says all men are mortals, so that's conclusive. And then no mortals are angels, so that totally separates men from angels. No matter what you think beyond that.
So I'm not following you.
Well, if all men are mortals, meaning they die, and no mortals are angels, so angels don't die, how can the two be exchanged?
Well, but look at the last. Therefore, some angels are not men. It would have to be, therefore, all angels are not what?
All angels are not men, yeah.
Right, but that's not what it says.
But it doesn't,
But it's also true that some angels are not men.
True.
If it's true of the whole, all angels are not men, it's also true of the part, some angels are not men.
Right.
so you're saying that it's not really saying that angels are men.
You're correct.
Correct.
Just because you're talking about part of angels doesn't mean you're saying anything about the other part.
Okay.
I'm not
And-
affirming or denying anything about the rest of the angels.
So again, though, Bart, your question is pointing out again the need for why we have to be really careful,
Precise, yeah.
precise. Okay, and again, this is why most people don't like logic, because it requires you to be more precise than most people to have care to be. Okay.
If we do have time, we can throw up that blog, that first paragraph, so you did want to try.
Okay. So here's what I'm going to say. I don't think I'm going to get through all this in 15 minutes. Because we still have 2 more rules and 15 minutes. So I'm going to make the executive decision. Got 4 more rules. I'm going to make the executive decision. Nate and I will powwow. We will either record something midweek, or we'll pick this up here next time. Nate, why don't you come up and walk us through your other example here? I think we benefit at this point from more of a practical.
Pull up that blog and because he wanted to do some practical examples, so give me that first paragraph in the blog.
Can you hand me the keyboard, please?
Nope. Locked out that side.
Okay.
Okay. Alright, that first paragraph. Okay, let's do. So this first paragraph, how do I get it up there?
It wasn't up there.
There we go. Okay. So we have theistic realism, i.e. Theistic conceptual realism. Those are not the same thing. So these are 2 different terms. Okay. Theistic realism is what a lot of people in apologetics look at, like Romans chapter 1, or when the psalmist says about the heavens declare the glory of God. Basically, theistic realism says that I can look at nature, use rational thought, logic to arrive at a concept of God. So I can use that sort of stuff. Conceptual realism, which he defines here, is that everything existed in the mind of God. So this is against Platonism that says objects like, or things like numbers exist outside of God. They're just these non-concrete objects that exist. So this one says, no, those objects only exist in the mind of God. So they're not the same thing. But for whatever reason, he's conflating these 2 terms. But let's try to, with this paragraph that he's starting to write, find an argument. So the first thing we're going to want to do is look in this paragraph for conclusion statements. We want statements, and then we want conclusion statements. Now remember, what are our key words that we're looking for when we want to look for people building an argument out?
that we would have a statement, but if it's a premise, what's it gonna have? Yeah, since this is God's use of words, okay? This would be God's use of exact words to mean exact concepts. Okay, so the conclusion is going to be this, right? It's going to be something with God use of exact words to mean exact concepts. So we'll just start with the conclusion. Therefore, God, and then if I'm going to make this into a categorical statement, how am I going to have to word this?
Is an exact word user.
God is an exact words to mean exact concepts user. This is why we boil it down to S&Ps, right? Because if I have to go by what he's saying, his conclusion, God is an exact words to mean exact concept user, is the whole P. God is, and we'll abbreviate, exact words equals exact concept user. EW equals EC user, right? So that's what I'm going to abbreviate that to. So looking at what he has here, what could I know since God uses words. So that's going to be my premise, one of my premises. So I have to have God and make that into a categorical statement. God is a words user, right? So God, that must be, I need it in my P2 then, right? Because this is my S is P, right? So P2, my premise 2 is going to be God is a word user. God is a word user. Okay, so then based on these two, can I make or construct a P1?
Yeah, it'd have to have something to do with exact words and.
Right, so I need a middle term, right? So this is going to be, this is my S, right? So this is going to be my middle term then. So I need to use my predicate up here and my middle term up here. So I need to use this and this to make a third, or my first premise to make this an argument. So give me an example, how could we combine these into a statement? It would be something probably like, word users are these, or these are these. Somehow, either some, all.
All word users.
This one would be all. This one would be all. So do we want, I mean, to make it make sense, it almost seems like it should be an all. All word users are that. So let's just do that. All M equals P. Or R. All M are P. Alright, so then if that's, basically we just constructed an argument based on his statements there, right? So in a blog post, this is the paragraph, we've extracted out one. There's actually at least 2 arguments in this paragraph. But this is one of the arguments in this paragraph. Okay, so then we can do our mood and figure and see if this is even valid. So what's the mood of this one? That's the 3 letters of the statement. The 3 statement letters.
AAA.
This is an AAA mood. And then what figure?
1.
That would be AA1, which I believe is a valid form. I believe AA1 was
That was
valid.
in your list from last week.
Yeah. Okay, so we did it. We made a valid argument here for it. Okay, so that's where we started that valid argument. So now that's where we found it's valid. Now we could start testing it by rules. All
Are they distributed? Are they this? And that's what's going to get you that form, is following all the rules and tell you whether or not it's valid. So we have a valid argument, but is it a true argument? So luckily we constructed it good enough that we gave him a valid argument. The other one in here that I'm seeing is, we have some statements. The key component of language is words. How would I write that as a statement? Or it is a statement, how would I write it as a categorical statement?
All languages are word users.
No, the key component
Oh.
of language is words. I mean, I'm already close to a categorical statement right there. I have a term. If I could make this more into a term, is my linking verb, words is my other term. So, now notice he doesn't say a key component of language is words. If he said a, what kind of a statement would I be using?
Particular.
Yeah, I would be using particular, so it would be some key component is words, or some
That's
words.
how it says the.
But it says the,
That's
so
the
then what am I? So now
All.
I'm, right, universal. So I have to have an all or a no. Now it looks like with the language there, it's gonna be all.
All components of language.
Are words. All words are key component of languages or something like that. Or
Are the key component.
all words are language key components or something like that. So this is going to be an all statement. Well, let's figure out which way we want to write this. So this is where I have all words are language key components. So I know I have one statement in there. All words are language key components. Okay, so we found one statement. Then we have another statement. Words represent concepts. That's a statement. How do I make that categorical?
It's all.
It's an all. So I have all words are
Concept representatives.
concept representatives, yep. Okay, then either I need to make one of these my conclusion, or I need to make a conclusion from those. So based on the context, what makes most sense?
Make a conclusion out of the two parentheses.
So combine these to make a conclusion, you think. Okay, so what's going to be my middle term then?
Words.
Yeah, words is going to be my middle term here. Then obviously if this is going to be our P1, this is going to be my predicate, this is going to be my subject. So I'm going to have all CR R LK C. Okay. So then I got an AAA mood. And what figure?
I don't remember the figures. The one with two on the one
Yeah.
side.
This would be a figure 3. So yeah, if you have, this would be M, P, S, M, and this is a 1, then it would be P, M, SM, then M, P, M, S, and then the opposite, P, M, M, S. So this one. So we're here, this one's 3. So there's our middle term. It's on
How'd
the,
you choose the third one over the second one?
what's that?
How'd you choose the third over the second?
Because the middle term is over on the left
On the
side.
left side. They're lined up.
So I got M, MP, M, S.
Oh, got it.
So AAA3, is that valid or invalid?
Invalid.
It's an invalid argument. So if I'm looking at this first paragraph, I've constructed 2 arguments from it. One's a valid argument, one's an invalid argument. So I can throw this one away and say, that's garbage. Now, if he's building out his case, he might have one valid argument, but is he relying on an invalid argument to build out his whole paper? So right in the first paragraph of this paper, do I need to read any further? Whatever he's going to conclude, it's garbage because he's starting